If we talk about what are the different uses of the coordination compounds, one great use is in the plants in the form of the chlorophyll. Then what else? If I talk about the chlorophyll, you would see that there is this magnesium, interesting magnesium complex that you observe. So this is a huge structure, but you see that nitrogen is donating some of the lone pairs and you get a coordinate compound if you observe here. And there's some ring formation, some chelation also at play, isn't it? Now, if we also talk about hemoglobin, our own blood, we are a moving coordination chemistry in our cells. We have blood, and when we talk about blood, what do we have? We have, look at this. In the flow of the blood, we have something very, very interesting. We have iron complex which comes up. So you can check in hemoglobin, again, you have the chelation happening. There is this iron 2 plus. It's kind of like, if you observe, it is inside these whole hydrophobic pockets that this iron 2 plus is present. Now, mind you, what are the conditions of rust? Can you guys tell me? This is a very interesting question. In our body, there is water. We are majorly composed of water. And when it comes to oxygen, of course, hemoglobin is an oxygen carrier. So we have oxygen, we have water. These are the conditions which are required for rust. Why does our body not get rusted? Why no corrosion? Can you answer me this? Why is there no corrosion happening, guys? It has nothing to do with the antioxidants, okay? Correct. So that is why this whole, what Sneha is giving us is a perfect answer. If you see these kind of rings that you see out here, these spiral rings are providing hydrophobic pockets. So this is where we have hydrophobic pockets coming up. And mind you, for the rust to happen, both the conditions has to be satisfied. Number one, there should be water. Number two, there has to be oxygen. Both conditions simultaneously has to be satisfied for this Fe2O3 to be formed. And by any means, if these kind of rings are disrupted, then there is this problem that can happen where a person's body may get affected and may get rusted, and that can be very deadly also. Okay, so yes, here comes the role of the coordination compounds in front of you. All right, next, vitamin B12. A particular vitamin which most of us who are vegetarian will have a deficiency of. So I do have a vitamin B12 deficiency, and how I could detect it was during my online classes, I used to get some of the mental fogging. Mental fogging is a great indicator that you have deficiency of vitamin B12. Another very important indicator that you have a deficiency of vitamin B12 is you will have a lot of joint pain. If you're standing for a very long duration, you will start feeling pain in your joints. So that is also coming from the deficiency of vitamin B12. You being students in your teenage or early 20s, it's very important for you that you maintain a good diet. Complete good sources of B12 should be taken up. Along with that, vitamin D is crucial. So vitamin B12 is all about coordination compound, which looks like this, where you have cobalt 2 plus in the center. And again, you can see there is a complex being formed. 1, 2, 3, 4, 5, 6. You can see there is a ring formation, again chelation here as well in vitamin B12. Cobalt 2 plus is our central ion, metal ion here. Okay, all of these are great examples. Another one for metallurgy. Again, metallurgy, there are so many complexes that we make and make use of the complexes in order to extract the metal, in order to purify the metals, expensive metals. For example, if I show you the list, it's huge. It is, of course, now this might not be very understandable, but these are industrial catalysts that I have shown. So many of the complexes are industrial catalysts. Now, like I was saying, in electroplating, in textile dyeing and medicinal chemistry, you being NEET aspirants, you would see Cisplatin, one of the important medicines for chemotherapy, right? It's all what? Coordination compounds, right? So welcome to this chapter, coordination chemistry, and let's explore it further now. All right.